So in this video I am going to solve educational code forces round 164 rated for division 2. So I will be solving first three problems of this problem set. So let's start with problem number A, that is a painting the ribbon. Okay, so in this question we will be having two players like Elias and Bob, and they are having a ribbon of n parts. Now they want to paint it. So first the turn is of Elias, and Elias, what she can do, she can choose, or I can say she have total m colors, and she can use that m colors to paint the ribbon in any part she want. Okay, now now what Bob will do, Bob will choose at most k parts of the ribbon and repaint them into the same color. Now what Elias want that my ribbon at the end does not have the all colors same, because she thinks that if all the colors are same in the ribbon, then that is a dull ribbon. So she does not want that to happen. So is it possible to paint the ribbon in such a way that at the end all the colors are not same? So how to solve this problem? Like there's a very much petri case, like if your n is equal to 1, then in this case at then your all the colors would be same at then. So in this case answer is simply no. But how to solve in the other cases? Let me tell you how we can solve. Okay, great. So let's suppose there is a ribbon. Okay, let me take a ribbon. So let's suppose it is a ribbon. Okay, so and it is having some number of parts, and I am cutting the parts of the ribbon. Although it is a very easy problem, but let me tell you the solution also. Okay, so let's suppose this is a ribbon, and total you are having, suppose let's suppose three number of colors. So how you will paint? Let's suppose I'm taking one here, one color here, two here, three here, one, two, three. So I will paint it in this manner. Okay, now, okay, one, two, three, and one. So what is the maximum number what is the color which is occurring maximum time? That is one only. And what is its count? The count of one is 1, 2, 3, 4, 5. So my one is occurring total number of 5 times in my ribbon. Okay, great. Now let's suppose this. So now tell me what should be the value of k such that you can always win, which means the number of values of color, which means that all the colors are not same at the end. So let's suppose you are having a, let's suppose k you are having a, let's suppose 7. Okay, so you can at most paint 7 colors. So greedily what you will do, you will try to paint all the colors equal to 1, because that is a number which is occurring most number of times, and it will be beneficial to you to color the less number of blocks at the end, so that all the colors become equal to 1 only, because you will always try to make all the colors to the maximum 1 also. Let's suppose you are, which means 1 is occurring maximum times in the array, so you will try to make all the other remaining account to equal to 1 only, because that's beneficial for me. Okay, now tell me whether, now you have to find whether you can make all the colors to 1 or not. If you are able to make all the colors equal to 1, then all the colors at the end would be same. But if you are not able to make all the colors equal to 1 at the end, then you are not able to. For example, in this case, what is the count? The count is simply 1, 2, 3, 4, 5, 6, 7, and 8. Which means if you are having a k equal to 7, then you cannot win, because because a minimum of 8 count is required to make all the colors of the ribbon equal. So that's why you cannot win in this case. But if your k is having a greater number than 8 or equal to it, then you can always win, because your number of ones plus number of k's would be greater than the length of your array itself, which means you can make all the colors equal to, you can make all the colors equal at the end. So that's how you can solve the problem array. So I will show the code is also pretty much intuitive. So first of all, what I'm doing, I'm finding the maximum occurrence of any number which can occur in my array. Okay, now finding the left number of arrays. For example, let my 1 is occurring 4 times, then my remaining number of count would be n minus number of 1, that is n minus 4. So that's what I'm showing in x only. Now just checking if your k is greater than equal to x, then simply put no, which means you cannot make a beautiful ribbon by using colors greater than equal to 1, but greater than 1, not equal to, just greater than 1, else you will simply put yes, which means you can win. So that's how you can solve the problem A. So let's now discuss the problem B, and the name of problem B is make it ugly. So in this question you are given a beautiful array, and you want to make all the elements same by using some number of operation. So what is the operation? Okay, for example, you are having, let me tell you here only. Let's suppose you are having three numbers. Let's suppose 3, 2, and 3. Okay, great. Now if you are, for example, if you are on this current index and your left and right index are equal, then what you can do, you can simply make middle one equal to left one only, which means my 3 2 3 will become equal to 3 3 and 3 only. So that's what this operation is defined. So a array is beautiful if you can make all the elements equal by using this number of operation, this type of operation. But this is not the problem. The problem we are asking like that, you are already given a beautiful array, which means by some number of this type of operation, you can make all the elements, you can make all the elements equal at the end, which means you are giving a beautiful array beforehand and you can make all the elements equal to, you can make all the elements equal. So what is question asking? So question is simply asking what is the minimum number of elements you can remove from the array such that your final array is not a beautiful array, which means by removing some number of elements from your current array, you cannot perform this type of operation and make all the elements equal at the end. So how you can solve this problem? Like it's a pretty much greedy solution only by solving this problem. Let me tell you why. So mm, let's suppose let's suppose this is I'm taking this array only, like 1 2 1 1, let's suppose 1, wait, like 1 2 1 2 and 1 2. Okay, let's suppose this is the array given to me. Okay, so in your beautiful array, your first and last number will always be equal, because that is the number which will decide the final array, because your first and last element cannot be changed at all. So tell me, can you change your last element by any some number of operation? You cannot. And similarly for the first number, you cannot change your first number, also you cannot change your last number. So that's why the at the end the final array would become equal to either would become equal to last number or first number. If they are not equal, then you cannot make it beautiful. But you are given that your current array is beautiful, which means the first and last number will always be equal. That's a case for sure. So now tell me how you can make this array non-beautiful. So let me take another example. For example, let I'm taking 1 2 1 2 2 1 1 1 2 1. So I'm taking this example. So tell me, in this case, can you make all the elements equal? I think so. No, I cannot make this element equal. But why? What is the observation which I'm saying here, and you are not able to? So that is simply like at the end, your all the elements will be equal to one only. Yes, and that's for sure, because your first number is one and your last number is one. Let me try to create it. Let's suppose these two I will replace it with one, because left and right equal to one only. Okay, now these two I will replace it with one. Okay, I'm able to one. So can you change these two to one? No, I cannot change this two equal to one. But why I cannot change? Because simply it's one side, its right hand side is one, which is the intended element which I want to such that all the elements equal to one only. But in the left side it is not equal to one, which means the middle one can never be become equal to one only, which is the first element itself. Which means in this question what I will try to do is that I will try to eliminate the maximum number of ones, which will the first number and the last number only, and which will be occurring the maximum times also, because that is a number which will be add then be the final number in my whole array. Okay, so what I will do, I will try to simply compress the array. For example, let's suppose I'm having a new test case like this. Let's suppose 1 2 3 1 1 3 1 1 2 1, let's suppose 3 1. Okay, so in this question, let's suppose it is a beautiful array. Yes, it is a beautiful array. But why? Let me tell you, because that is equal to 1, I can make it 1, I can make it 1, I can make it 1, and I can make it 1. So my add then all the elements are equal to 1. But that's not what I want. I want all my array not to be beautiful. So let's suppose these two ones are not there. Okay, let me erase it. Let me suppose these two ones are not there. Can you make it equal to 1 now? No, I cannot make, because you can make this equal to 1, you can make this equal to 1, you can make this equal to 1 also. But you can never make these 3 equal to 1 and these 2 equal to 1. So what I'm trying to say is like that, first of all find the maximum number, first of all try to find the intended uh, number which will be at then become the which will become equal to the which will become the maximum time number in my final array. That is the first number itself and the last number itself. Now try to eliminate that number between any two numbers. Okay, but how? Let's suppose in this case, first of all let me eliminate these two ones. Okay, if I eliminate these two ones, then the consecutive adjacent number are not equal to my maximum number, that is the first number itself. So what you will try to do in each and every step is like compare the number of consecutive ones. Okay, compare the number of consecutive ones, and the point where you find the minimum such consecutive ones, that is your answer. Let's suppose in this case the minimum number of consecutive ones is one only, which is occurring at this point. So what I will do, I'll simply erase this one from here, and you cannot make all the elements equal to 1 now. Yes, I cannot make. So in this case your answer is simply 1. So that's what I'm trying to say here. So let me show you the implementation. The implementation is also very easy. What I'm doing here is like, this is a little bit. So what I'm doing simply, I'm simply taking a map and first of all checking if the all the elements are equal, then definitely you can never make the array non-beautiful. It will be beautiful at the end. So if your all the elements are equal, then simply print -1 and return. Okay. Then find the maximum number which will be occurring. Okay, that is a max number. What I'm trying to say is that now what I'm doing, I simply try to find the all the occurrences of the non-maximum numbers, like the non-maximum numbers. Okay, then and finding the difference between them, finding the adjacent difference between them. So that's what I'm trying to do here. Simply the number of consecutive ones, also number of consecutive ones, or the difference between the non-maximum ones. So that's the only one thing what I'm trying to say. So the minimum of all this would be my final answer, and that's how you can solve the problem B. It's a very much pretty good problem for as a beginner level and of a level B problem type. So let's now discuss the problem C. That is the, I could say, the most simpler one in the whole problem set. But why? So in this question you are given two integer strings s1, s and 2, s and t, whatever, x and y. You can say that x and y, and these strings are very much high. You cannot take input as a integer. So you have to take them as a string in your code. So what question is asking, simply like you have to swap the adjacent numbers. For example, the ith digit of x can be swapped with the ith digit of y. Okay, now what is question asking you to do, you can perform any number of times operation in these two strings. Okay, let's suppose it is 73 and 31. What I will do, I will simply swap this one with these three, and that will become equal to 71 and 33. So that is the operation which you can perform, and you can find that your 73, let's suppose 73 into 31, that is 2263. Okay, and your 71 into let's put 33, that is 2343. That is definitely bigger. So that's what is questioning asking you to do. Simply you can swap any of the ith position, and what you will do, you will simply print both the string in the end such that the product of both of them is maximum possible. So that's what question is asking you through. First of all, you can swap any of the adjacent ith position, and at the end you have to print the two strings at the end such that the product of both the strings is maximum as possible. So how to solve this problem? So there's a pretty much little proof before it. Let me tell you why, but let me tell you what is that proof. So that proof is simply like, let's suppose you are having two numbers, let's suppose n and n. Okay, though n into n is always be greater than n minus 1 and n plus 1. Now let me write it clearly. Your n into n will be always be greater than n minus 1 multiplied by your n plus 1. Okay, now it will be always be greater than your n minus 2 multiplied by n plus 2. Okay, great. So n plus 2. So that's what question is asking you to do. Simply, what is this statement representing? This statement is simply representing if your number are closer, then they will yield the maximum possible product. If your number are closer, then they will yield the maximum possible product. I will repeat it again. If the difference between the both of the numbers is least, then they will yield the maximum possible product. So that's what I'm trying to say here. So in this question, your n into n is always greater than n minus 1 into n plus 1. That is always greater than n minus 2 into n plus 2. Okay, hope you are getting the point what I'm trying to say here. So in this question, what you have to do, you have to simply minimize the difference between both of the number. So how you can minimize the difference? So simply there is also pretty much greedy algorithm which you can find. But what I have done in the live context, I've just Googled it how I can find the minimum difference between any two number, and the solution which I get is simply like that. First of all, compare the first number itself, first digit of both the digits, first digit of both the numbers, and your the and make one of the digit as maximum and other as minimum. Let's suppose it is 8 and it is 2. Okay, one is maximum, one is minimum, and rest of the numbers, my number starting with a would contain the minimum digits, and my number starting with 2 would contain the maximum digits. Okay, so that's how you can make the difference between both the numbers as minimum as possible. So that is what question is asking you to do. Simply implement this part and your question is ready, your answer is ready. So what I'm doing, simply swapping, simply making my first number as a larger. Okay, if for a of I is smaller than b of I, then simply swap both of them. But in each and every other case, let's throw from I is equal to 1 to n, just make your a of I smaller than b of I and print a and b. So that is what question is asking you to do. Simply you can find the more better, you can see the more better explanation of C in the comment section also. So that is what I was here to solve in this problem set. So if you have any doubt, you can comment me down. Until this, stay tuned for the next one. Thank you. Welcome.